Hello everyone, in this lesson we will cover iteration. Our iteration formula is xn plus 1 equals xn plus 6. This is also known as a term-to-term formula because when we know a term, let's say xn, we can work out the next term. In our example, the first term is given, x1 is given. All we have to do is plug in x1, add 6 to it to work out the next term. To work out the first 5 terms of the sequence, we will start with replacing n with a 1. Our term-to-term formula will be x1 plus 1. This is equal to x1 plus 6. x1 is 4, so therefore x2 is equal to 4 plus 6, which is 10. When n is equal to 2, we replace all the n's in the term-to-term formula with a 2. This will be x2 plus 1 is equal to x2 plus 6. We found the x2 in the previous line, therefore the x3 will be 10 plus 6, which is 16. When n is equal to 3, our iteration formula becomes x3 plus 1 equals x3 plus 6. This will give us the fourth term. Our x3 has been worked out in the previous line. x4 is equal to 16 plus 6 equals 22. Let's continue. When n is equal to 4, we will have x4 plus 1 equals x4 plus 6. That is, x5 equals 22 plus 6 equals 28. The first 5 terms are 4, 10, 16, 22, and 28. We can interpret this as each term is the previous term plus 6. Example 2. Now we have the first and the second term given. Our iteration formula is xn plus 2 is equal to 2xn plus 1 minus xn. And we need to work out the x5. We can start by taking n as equal to 1. This will give us x1 plus 2 is equal to 2x, 1 plus 1, minus x1. x3 is equal to 2x2 minus x1. We already know the x1, which is 4. The x2 is 5. These were given at the start. Next step is to substitute them. This is equal to 2 times 5 minus 4. Therefore, x3 is equal to 6. Let's work at the next term. When n is equal to 2, x2 plus 2 is equal to 2x2 plus 1 minus x2. Notice again the n has been replaced by 2. Notice that 2xn plus 1 is a 2x2 plus 1 this time. And the xn became an x2 because n is a 2 in this case. Simplifying this will become x4 is equal to 2x3 minus x2 equals 2 times 6 minus 5 equals 7. Now we've got the x4, we need one more calculation to work out x5. When n is equal to 3, x5 is equal to 2x4 minus x3. x4 was a 7 minus x3 was a 6 equals 8. Therefore, the solution is x5 is equal to 8. Let's look at a more challenging example. Example 3. Solve x is equal to square root of x plus 1 by the quadratic formula and then solve it by iteration. Let's write out the quadratic formula. X is equal to minus b plus minus square root of b squared minus 4ac over 2a. The quadratic form can be written as ax squared plus bx plus c. But we don't have an x squared in our equation. What shall we do? Well, if we square both sides, we will have x squared equals x plus 1. Rearranging this now is comparable with the quadratic form. By comparing coefficients, we can see that our a is equal to 1. The coefficient of x is equal to minus 1, that's our b, and our c is equal to minus 1. Now we can plug in these values into the quadratic formula. This gets simplified as 1 plus minus square root of 5 over 2, giving us the two values of x, which are 1.618 to 3 decimal places and minus 0.618. Let's see how can we solve this equation by iteration. In order to do that, we need a starting value. So normally in a GCSE exam, the starting value is given. The subject of the formula can be written as xn plus 1, and the other x can be rewritten as xn. Because the x0 is given, we will start with n0. xn plus 1 will become x1, that is equal to square root of x0 plus 1. Replacing now the x0 by a 1 because that's given, will become square root of 1 plus 1, square root of 2. Using our calculator, writing out all the values on the calculator will be 1.414213,562. Continuing, when n is equal to 1, we will find x2. Because we already worked out the answer, we still have it stored in the answer button. So what we need to do now to make our calculation much quicker, we're gonna type in square root of, press the answer button, and then plus 1, and press equal. So we have just created our iteration formula on our calculator. To work out x3, all you have to do, just press equal once. Now, if we press equal one more time, that will give us x4. So every time we press the equal sign, because we have already created the iteration formula, it will give us the next term and the next term and the next term, until the value on our calculator approaches to one particular number. Notice that the more we press the equal sign, the more the answers approach to 1.618, which was one of our answers that we have worked out with the quadratic formula. Our starting point was x0 is equal to 1. If we would have started with a different value, it could have instead converged to the other answer. However, in some cases, depending on the equation, the answers don't converge, they don't settle at one particular point. In that case, we wouldn't be able to solve that equation by iteration. That means that the values would diverge. Now let's look at an exam style question. Show that this equation can be rearranged to give x equals 1/5 minus x cubed over 5. The subject of the formula is x, and on the right hand side we will have an x cubed. So first subtract x cubed. This will give us 5x is equal to 1 minus x cubed. Dividing by 5 will become x equals 1/5 minus x cubed over 5 as required. Starting with x0, use the iteration formula twice to find an estimate for the solution x cubed plus 5x is equal to 1. Since we have x0 given, we will start by replacing n with a 0. This will become x0 plus 1 is equal to 1/5 minus x0 cubed over 5. Notice we have replaced the n's with a 0. And that is equal to 0.2. When n is equal to 1, the xn plus 1 will become x1 plus 1. And this is equal to 0.1984. We have now used the iteration formula twice. The estimated solution for our equation is 0.1984.